About the analysis of portal frames in structural engineering second volume. Firstly, the fixed end moments of a member, any member, the member having fixed ends and the member is simply held in between both ends, that is point A and point B. There are two moments acting on this member. One is a anti-clockwise moment and other is the clockwise moment at B and A respectively. So fixed end moment at moment AB will be negative anti-clockwise of WL square by 2L, and moment about BA will be positive clockwise of WL square by 2L. And nextly, fixed end beam having a point load at midpoint. That means two moments of MAB and MBA are acting at A and B respectively. There MAB is anti-clockwise. This is opposite to the clockwise direction. So anti-clockwise WL by 8 and clockwise moment is positive WL by 8, and the fixed end moments having point load without symmetricity. That means at a distance of small a from capital A point and at a distance of small b from capital B point. Two moments MAB and MBA are, MAB is negative anti-clockwise of WA square B by L square and clockwise moment is WB square into A by L square, and moment acting at the center of the beam, that is fixed ended beam. Then whole moment is equal to the acting moment by fourth part at the both ends. This is the anti-clockwise and this is the clockwise. Next, distribution factor. Distribution factor of any member is determined by knowing the stiffness of a single member to the stiffness of a total joint. For example, we assume that a point is having a B next and a member is A and also another member C. The point starts from B and ends at A and C. This member is having fixed end at the end, so that the stiffness of this member is 3 by 4I and the stiffness of this member is 4 by 4I, that is nothing but I by L for any stiffness factor. So that now total stiffness of point B becomes K of B and K of A, KB plus Ka, so that it becomes 3 by 4 I by L plus 4 by 4 I by L. The whole sum moment will be 7 I by 4L. So that now this is the sum of total stiffness. Now the distribution factor comes stiffness factor of a single member by stiffness factor of total joint. Single member, we assume that BC stiffness factor is nothing but 3 by 4 I by L, and whole distribution factor of joint is 7 I by 4L. This gives 4L cancel, 3 by 7. This is the stiffness of BC. And the stiffness of BA is nothing but 1 minus stiffness of BC, that is 3 by 7. This gives the stiffness of AB, stiffness factor of distribution factor of AB. Now coming to the point, rules for analyzing of frames. There are some particular rules to analyze this type of frame structure. First one, rule number 1, that is all the members and the joints are assumed to be fixed ends. That means you see there are 4 joints here. Each joint is, here it is a fixed joint, here it is hinged, here it is hinged, here it is also fixed. So that first assumption in this is we should assume that these all ends are fixed. That means we consider this C and D as fixed. Here it comes C, here it comes D. Both are fixed, and UDL is playing in between them. And between CB it is also fixed and with a point load, and between BA it is fixed, both are fixed. We should assume that. This is the first rule in the analyzing of frames. Next, fixity of hinged joint is to be removed by providing anti-moment, and fixed end moment should be calculated. Fixed end moments are nothing but, we consider a beam C and D having a 100,000 Newton per meter UDL. We had a formula for UDL, fixed beam with UDL, WL square by 12 moment. We calculate the moment. That gives the moment about A and B, moment about C and moment about D. These should be balanced by the balancing moments. This calculation should be done until the balanced moments will become equal. Stop. Now see friends, here in this frame we consider the member CD. We are assuming it as fixed ended. So here it comes C, here it comes D. There is a UDL of 1000 Newton per meter. 1000 Newton per meter. We had formula moment about D to C. Fixed end moment is nothing but WL square by 12. W is nothing but 1000 and length is nothing but 6 meter. Moment about DC is nothing but 1000 into length plus 6 into 6 square by 12. This is nothing but 3000 Newton into meter. This is moment about DC. This is anti-clockwise 3000 Newton into meter. But if we consider the clockwise moment in DC, CD that gives positive 3000 Newton into meter. At this point, it is hinged in the given question, but we are assuming it as fixed ended, so that it should be rigidly remove the fixity. We should remove the rigidly its fixity. That means we should give oppositely this positive. The moment which was given here for the balancing this junction is transferred, some amount of it is transferred to this joint. That means moment above DC will be accurately increasing due to the transferring. This transferring comes under the carryover factor. Carryover factor is the ratio through which it is carried. Carryover factor is normally half. That means if we apply here a 1 Newton into meter moment, in that half of the moment is transferred to this section. That means